All right, in Chapter 6, we're going to start looking at how we can find trig values of angles that are bigger than 180 degrees or 90 degrees, bigger than 180 degrees, smaller than 0 degrees, basically any angle we want. So in general, we've been looking at a right triangle, picking an angle, and then finding the trig ratio of that with, SOHCAHTOA and things like that. But we know from earlier we can have bigger angles than that. And I'm going to graph this angle on the coordinate plane. So I'll start here and maybe I'll end here. So I could go this direction and have a big positive angle, or I could go this way and have a negative angle. We call this standard position. So with these angles in standard position, and recall when they rotate clockwise, this is actually negative. So when it starts by going down, it's negative, and it's when it goes up, it is a positive angle. So we're going to look at angles, basically any angle in this standard position, and try to find the trig values of it. Now to do this, we're going to use what is called a reference angle. Now a reference angle is simply going to be an acute angle. So remember, an acute angle means it's less than 90 degrees, formed by the x-axis and the terminal ray of an angle. Now, terminal ray we just typically say is the second of the two rays, because we have two rays that form our angle in standard position. So if, for say, my angle is here, and I go in this direction, let's say this is my angle theta here, then my reference angle is going to be between that last ray and the x-axis, would be right here. So I might call it theta prime. Theta prime is a pretty typical notation for a reference angle. If it's in a different quadrant, let's say that it is in quadrant 3. So my angle goes all the way around here. Well, the acute angle that's formed between this terminal ray and the x-axis would be this little angle in here. So it's the angle left over. So depending on what quadrant you are, the reference angle can look very different. And reference angles will be very important when we try to actually figure out some of these trig values. Another thing that's very interesting is the trig values functions can have different values in different quadrants. So the trig function values, the trig values change dependent on the quadrant. So different quadrants have different signs of their trig value. Now when I say signs, I mean negative or positive. So there's a really easy little acronym to remember which quadrants, which ones are positive. We call it ASTC. A stands for all. So if you have an angle that ends in the first quadrant, all the trig function values are positive. If you have one that ends in the second quadrant, then the sine value is positive, and cosine and tangent are negative. And if you are in the third quadrant, tangent is positive, and the other two are negative. And if you're in the fourth quadrant, cosine is positive, and the other two are negative. Now, all this will be sorted out when we look at how we actually find these values. So it's not imperative that you know this, because when you actually use this stuff. So how we actually will figure it out, the trigonometric values of any angle are actually related to their reference angle. So this is kind of the most important thing we've seen yet. So the trig values of any angle are the same as its reference angle. The only thing that could be different, its sign may be different. And the key word here is may be different. It could be the same. So typically a reference angle, the trig functional values are positive, but your angle could have a negative value depending on what quadrant it's in. But really, all this really boils down to if you can see your reference angle, it really can help you to find your trig value of any angle. So let's look at a couple concrete examples of how this works. So this first one says, given the sine of theta equals 1/5, and theta is between 90 and 180 degrees, find the other 5 trigonometric function values. So the first thing I know is that we are going to be in quadrant 2, because it says this angle theta is somewhere between 90 and 180 degrees. So I'm going to draw some angle over there. It doesn't really matter where it is. So it's somewhere in this quadrant. This is angle theta. So the goal of this problem eventually is to find what is the sine of theta, what is the cosine, well I guess we already know the sine, but the other 5, tangent of theta, cosecant of theta, secant of theta, and cotangent of theta. Well, I already know what the sine of theta is. Sine of theta is 1/5, so I automatically know the cosecant is 5, because if you recall from the previous chapter, sine and cosecant are reciprocals. So what we'll do now is we'll look for the reference angle. Because remember, we said this trig function value, the cosine of theta and all this stuff, is the same as the reference angle, except for it could be different by sine. So if we look at the reference angle is right here, because it's between that terminal ray and the x-axis. So what we can do now to solve problems like that is, now that we know this is our reference angle, I'm actually just going to drop a vertical line straight down, and what you'll see happens is I have a right triangle that has my reference angle. Now, since this reference angle has the same trig value as my original angle, I also will know the sine of my reference angle is 1/5, because recall sine of theta is positive in quadrant 2. So since sine is opposite over hypotenuse, in my triangle I know this side is 1 and this side is 5. So I'm going to claim I can find the other side using Pythagorean theorem. So if I do 5 squared equals 1 squared plus x squared, because x is the bottom side, then I get 25 equals 1 plus x squared. I'll subtract 1 from both sides, which gives me 24. And then I can take the square root. And now the square root of 24 simplifies to 2 radical 6. But here's what I want to really point out, because we talked about this earlier. When I take the square root, I really do need to add the plus and minus. Now in this problem, since the x direction on the coordinate plane is negative, this is actually going to be negative 2 radical 6. So the fact that we are going left, because you know if you go left of the origin, that's a negative x direction, that's how we actually get the negative value for this triangle. So now since I have this triangle now, all I have to do is do the opposite and adjacent and all that good stuff. So cosine is adjacent 2 radical 6 over 5. Secant would be the reciprocal of that. It would be negative 5 over 2 radical 6. And if I wanted to rationalize that, that's negative 5 radical 6 over 12. Tangent is opposite over adjacent. So that's negative 1 over negative 2 radical 6, which is negative radical 6 over 12. And this would be negative 2 radical 6 over 1. So you can see that since we are in quadrant 2, 4 of these ratios turned out to be negative, and the only one that turned out to be positive was sine. And if we look above at the chart, quadrant 2 was the sine. Sine was the only thing that should be positive. And of course, it's reciprocal identity of cosecant. So setting up this reference angle, reference triangle as we call it, is a really nice, easy way to find these trig values. Now, we don't always have these. It doesn't always work out so nice. But when it does, it's pretty simple. So let's look at another question. It says, what is the reference angle of 200? Well, this is a little more direct question. So first thing I do is graph 200. So it starts here. There's 90. There's 180. So we go a little bit past. So There's a 200-degree angle. Now the reference angle is always between the last ray, the terminal ray, and the x-axis, so it's this little angle here. So in this case, to find my reference angle here, I'm just going to subtract 180 from this. So 200 minus 180 is 20. So this reference angle is 20. And so what this will tell us from our above theory, so the sine of 200 is going to be the same as the sine of the reference angle, except for it could be negative, it could be positive. And since in this quadrant, remember, all is positive, sine is positive, tangent is positive, and cosine is positive, sine is definitely going to be negative in there. So the sine of 200 is the negative of whatever the sine of 20 is. Now, the hard part about answering this, and we really can't answer this right now, is we really don't know what the sine of 20 degrees is. Now, the only ones we really could do is if it was 30, 45, or 60, because we do know those triangles and their ratios, how they work out every time. All right, let's look at a couple other kind of problems that you might encounter when you're looking at these general angles. You can also figure out where an angle lies by just knowing parts of the trig function sine value of this angle. For example, it says name the quadrant angle beta lies in if the cosine of that angle is positive but the tangent is negative. So remember our quadrants. We know that everything is positive in quadrant 1. Just the sine is positive in quadrant 2, just the tangent in quadrant 3, and the cosine is positive in quadrant 4. So it says the cosine is positive. Well, the cosine is only positive in quadrant 1 and in quadrant 4. It is negative in quadrants 2 and 3. And it says the tangent is negative. Well, tangent is negative in quadrant 2, and it is negative in quadrant 4 because it's positive in quadrant 1 because all the trig function values are positive in quadrant 1, and it is positive in quadrant 3 because there's our t. So somehow I know, since the only overlapping is in quadrant 4, I know this angle has to be in quadrant 4. So what that entails is if I were to graph this angle, it goes, down here somewhere. Now it could go negative. It certainly could go positive. It doesn't really matter because remember, everything's really only based on that reference angle. But whatever it is, it's going to have a positive cosine value and a negative tangent value. All right, let's look at another example that's similar to the first one we did. It says, given the cosine of theta equals negative 2/3, and theta is between pi over 2 and pi. So it might be convenient to convert these to degrees. Pi over 2 times 180 over pi. Remember, that's going to be 180 over 2. That's 90 degrees. And if I do pi times 180 over pi, that's just 180. So this is saying this is between 90 and 180. So if I draw that on my coordinate plane, here's the first side, and it's going to be somewhere over here because here's 90 and here's 180. So, and it doesn't really matter which direction it goes. We'll just say it goes positive. That doesn't really have to be the case. So there's my angle theta. So more importantly, my reference angle is right there. So in this case, I know that the cosine of angle theta is negative 2/3. So in my reference triangle, that I'll drop right down here, I know that's adjacent over hypotenuse. So the adjacent is negative 2 and the hypotenuse is 3. We really don't know which side is negative, but since the hypotenuse is always assumed to be positive, then it has to be that adjacent side is negative. Now when I do Pythagorean theorem to find the other side, 3 squared equals negative 2 squared plus y squared. So that's 9 equals 4 plus y squared. I'll subtract 4, which gives me 5 equal to y squared. So it's equal to plus or minus the square root of 5. But in this case, since my y in this direction, it's going up, because in this direction that's a positive y value, it's going to be positive square root of 5. Again, it's just based on the quadrants, and in quadrant 2, all the y's are positive. So now that we have that, we can find all our trig function values. So the sine of theta is opposite over hypotenuse, that's radical 5 over 3. And it's positive, which makes sense, because remember, everything is positive, sine is positive, tangent is positive, and cosine is positive. So we would expect sine to be positive there. I should have filled this out. This is quadrant 2. Cosine was given to us. That is negative 2/3. And tangent is opposite over adjacent. So it's radical 5 over negative 2. And you can find the other 3 just by taking the reciprocals. So if I wanted to find cosecant, it's 3 over radical 5, and you could rationalize that. The secant is negative 3 over 2, and the cotangent is negative 2 over radical 5. And you could rationalize that. So really finding these bigger angles or smaller angles or whatever you want to do, it really is the same as just finding the trig function of a smaller angle. The problem is you have to know something like this. Like this has to be given. So if it's not given, that makes it much harder. So let's look at one more example. I'm going to tell you that the cosine of 15 degrees is this really awful number. It is the square root of 2 plus the square root of 3 all over 2. And this is actually a true statement. So I want to find the value of cosine of 165. Now here's how this can help us. So if I look at 165 degrees is somewhere over here. Because I go 90 and then I get a little more, but I'm a little short of 180. But what you'll notice is the reference angle which is left over here, is 15 degrees, which is what I'm given. So I know the cosine of 165 is the exact same as the cosine of 15, except it might be the opposite sign. So we have to look at the quadrants. Is cosine positive or negative in quadrant 2? Remember, we had all sine, tangent, and cosine. So the only thing positive in quadrant 2 is sine. So in this case, cosine of 165 would have to be negative. So the cosine of 165 is negative cosine 15, but cosine 15 is 2 plus the square root of 3 all over 2. 2 on the outside of the radical. So if you tell me the cosine of the reference angle, since I know cosine has to be negative in that quadrant, I can find that one. Similar thing works for cosine 345. So let's look at where cosine of 345 lies. So here is 345. As an angle, it's way over there. So this is 345 degrees. So our reference angle is this little guy here. It's how much is left between that last side and the x-axis. In this case, that's 15 degrees. Now again, we have all sine, tangent, and cosine. So in this case, cosine is positive. So the cosine of 345 is exactly the same as the cosine of 15, which is its reference angle. Because again, cosine in this quadrant is positive. So the cosine of 345 degrees is equal to radical 2 plus radical 3 all over 2. Another example that we could do that I didn't really talk about is we could do a bigger angle that we really don't know a triangle about. So this is kind of one that wasn't on your notes, but let's just say I want to know what's the cosine of 120 degrees. Well, if I look at 120 degrees, That is in quadrant 2. It goes over here. It's 120 degrees. So my reference angle is 60. So the cosine of 120 is the same as the cosine of 60, except for it could be a different sign. And in this quadrant, all sine, tangent, cosine, it is the opposite sign. Cosine is negative in quadrant 2, so it's negative. So if I could find the cosine of 60, I would have my answer done. So how I could do this is I can draw my triangle, because I know from a 60-degree triangle, 60, 30, 90 triangle, I know these have ratios of radical 3, 1, and 2. So the cosine is going to be the adjacent over hypotenuse. Well, in this triangle, if this is my angle, this is opposite, this is hypotenuse, and this is adjacent. So the adjacent over hypotenuse is 1 over 2. So the cosine of 120 is negative 1 over 2. So really some pretty simplistic ways to find the trig function values of bigger angles. We will actually simplify this in the next section to use what's called the unit circle that helps us find a lot of these exact values.